For this question, the first thing to notice is that you have a product of two functions here because you have x times tangent, and you also have a division of a variable expression over a variable expression, and there's no way out of that. So you would have to use the quotient rule to start off, and then in the process of taking the derivative of the top, this would require the product rule. And then in the denominator, because you have a square root, you would have to rewrite that as 2x plus 1 to the 1/2 power, which would then require the general power rule. So in looking at this, it's just like there's too many rules to deal with. You have the product quotient and GPR, and so when that happens, when you have a mix of all these different rules, that is when you want to use log differentiation. And the purpose of log differentiation is that hopefully what you will see happen is a simplification of the function. So instead of using all this general power rule, quotient rule, we're going to use log differentiation. All right, so we'll start with the function as y is equal to x tangent square root of 2x plus 1. And then I'm going to take, as my first step of log differentiation, I'm going to take the natural log of the left-hand side, and I'm going to take the natural log of the right-hand side. So at that point, what I want to do is I want to simplify. So I take the log, and then I'm going to simplify the right-hand side. So I'll have the natural log of y, and then on the right-hand side, I have x times tangent, so that becomes tangent x, so that becomes an addition of two logarithms. So in the numerator here, I have multiplication, so that becomes addition of natural log of x plus natural log of tangent x. So that's my numerator minus the natural log of my denominator. Now, when you look at your denominator, you have a square root. So anytime we're trying to take the radical, we always rewrite that as a power. So this is going to be to the 1/2 power. So what I'll really have with the rewritten radical is I'll have minus 2x plus 1 to the 1/2 power. All right, so now I have used the multiplication property, I've used the division property, and now I'm going to bring this power down as part of my simplification. So the powers will become coefficients. So this will become natural log of x plus natural log tan x minus 1/2 natural log 2x plus 1 is equal to the natural log of y. Now, at that point, I have used all my properties, so I'm now ready to take the derivative. And to take the derivative, I'm basically going to be using the fact that natural log of some argument is equal to u prime over u. So here I have the natural log of y, and so that's going to become y in the denominator, and the derivative of y is y prime equals, and then here my argument is x tangent x and 2x plus 1. So those are going to go in the denominator as I differentiate term by term here. So I will have x in the denominator, the derivative of x is just 1, plus tangent, the argument in the denominator, the derivative of tangent is secant squared x. Again, you need one tangent and two secants total. Minus 1/2, and then here my argument is in the denominator as 2x plus 1, and then I take the derivative of that argument, and the derivative of 2x is just going to be 2. Now, at this point, you do have one simplification that's very obvious. These 2's can cross out because you have multiplication, and that will be undone by division. So you're really just left with 1 in the numerator. Now, you do not need to get a common denominator or anything of that nature, but what you do have to do is solve for y prime. So what we're going to do is we're going to multiply the left and the right by y to isolate the y prime. So on the left-hand side, I multiply by y, those cancel, and then on the right-hand side, I multiply by y, and nothing cancels. So I get y prime is equal to y times all of this 1 over x plus secant squared x over tangent x minus 1 over 2x plus 1. And because this 2x plus 1 is the only thing in the denominator, I can drop the parentheses at that time. Now, before we can finish this up, this right-hand side has to be all in terms of x. So what we're going to do is we are going to substitute in the definition of y. So y was defined as our function. So from the very, very beginning of the problem, we had that this whole function was defined as our y. So we will substitute that in, and we'll say it's x times tangent x over the square root of 2x plus 1. And then in brackets here, we'll multiply by all of this. So this 1 over x plus secant squared x over tangent. And you could convert this into sine and cosine and try to simplify, but it's not really necessary at this point, okay? And that would be equal to our y prime.